Right.
So his reason for using Mocha is that they find the API that Mocha gives you easier to understand and more readable than FlexMock. And there are some surprises that you can get from FlexMock, but I think you can also get those surprises from. Yeah. So it's basically like a cat and dog thing, I think. Cat person versus a dog person, right?
And as we all know, cat people are mad.
Yeah.
So, all right, if you weren't really paying attention up until this point, now is the time, because I believe I've recently started using FlexMock seriously, and I believe it has made a significant improvement in my ability to write code just in the past few months. And part of the reason for that is I always thought of mocking frameworks as something you pull out when you need to do mocking. Like I have this event, which is I need to do mocking now. So let me get the mock library out and try to remember how to use it. And actually working on a project with Marcel, I saw he was doing a lot of one-liners with FlexMock, where you just use it all over the place, but you use it in a very, very simple way instead of the kind of big constructs you find in the documentation. So I'm going to tell you right now that I think every time you write a test unit test case that's of any significant complexity, you should probably, even for now, find a reason to use mocking, because there probably are reasons that you don't know about if you're not using it.
It's not just this thing is going to be talking to the file system, this thing is going to be talking to the network, and I need to fake that for the test. It's useful for all kinds of things, and it's useful. Right. So there's some things that you would always be mocking, but there's also situations where for one specific test scenario, you're dealing with a specific detail that doesn't have to do with this other detail. So you're going to mock that detail because you don't have to deal with setting it up because it's not the primary concern. And then in another test, that thing that you had mocked elsewhere, you're actually testing. So it's not just things that have to be simulated to isolate them from the real world. There's some scenarios where it's way better to not have to deal with the complexities of the details, or the details even if they're not complex, because they're not the point. And it's a lot easier to say, this thing is going to return true because in this scenario that's what's important. But in another scenario, you're actually testing the fact that it's returning true for the right reasons. So my point is, mocks and stuff aren't a all or nothing thing where like there's certain things that are mocked and that's how they exist. It's really useful in some situations to just say, instead of doing all this ancillary setup for the specific thing I want to test, I'm just going to make that stuff do what I expect for this particular scenario and ensure that as a result of that, this other thing in real life does what I'm expecting. Right? So his question is, do you leave those mocks in or do you replace them when you actually do something or other? The way that FlexMock works is that if inside of a given test, I say that something should receive a given message and return a certain value, it's going to enforce that expectation for the lifetime of that test, and then it rips that mock out. So I don't...
I leave it as a mock. So when you use mocking to get started, like a bootstrapping kind of method, do you go back and replace the mock in the test with the real implementation class? And I typically don't at this point. Right, that's true. So, question, we have about 40 minutes left.
Really?
Yeah. We're gonna launch into this mocking stuff. Should we take a quick break before we finish? Who wants to take a quick break before we finish? A few. Let's call it 5 minutes then, and then we'll come back to the mocking stuff and wrap up. So we'll hold strictly to 5 minutes.
Oh, okay. Oh, can I even get online?
Just so everybody...
Wireless? Yeah, we could go over, I think we should go over that, like the last. See,
What's nice is that the clock is compared to the Xbox is exactly the same as the one that works. So the vocabulary is
Do you want to maybe come up at the end and plug your laptop?
I think sure. All right, I'm trying to USB key.
yeah, that's a cool idea. Thanks.
I was just going to let everyone know that we do have some drinks back over on the right. Not the ones in the cooler; those are Red Hats. But there's some soda and some bottled water over in the back of the room. You're welcome to that. And also, if you have not yet donated, you can get on the wireless network now. Feel free to grab somebody who has a laptop and ask them if you can use their laptop to get on if you want to, and go go ahead and give your donation to Changing the Present.
Yeah, I was noticing all the toys back here too. Not enough time to get it yet. Came out, my wife said, so vacation. I'm sure you're ready. Some guy in a cowboy hat. Oh, wow. Good to meet you.
behind us and help organize it. Oh, it is. Okay, let's get started again. If you want to find your seats, please. We have about 30 minutes left. So what are we going to do first? We're getting into mocking territory. I'm going to mock here. I assert that this is not what we want to do yet.
Okay.
I think what we want to do is we want to actually have this happen in the dealer test because we're still testing the dealer. And we want to show that when you tell the dealer to draw a card, the dealer actually draws a card from the deck.
Okay, that's a good point. Anyone not catch that?
Did anyone catch it? 2 people caught it, 3. So what I'm saying is we're at this point where we're saying dealer.draw gives you a card. That's fine. But we also want to test that it actually removes the card from the deck. But we don't have any kind of a concept of a deck implemented yet. So instead of going down the rat hole of the deck, now we can just use a mock in a way that actually would be lasting because we do want to sort of test that the dealer is interacting with a thing appropriately. So what will the dealer do with the deck? Do we want to make a new test for this? Or
I think we don't. I think what we're going to do here is we're going to say, so we already have this dealer object that's created here in setup. So with FlexMock, we're going to do FlexMock. We're going to pass it the dealer object. And by passing it the dealer object, it's going to add some behavior to this dealer. So we're going to say dealer should receive, receive. Receive.
Yeah.
I always have difficulty with that. Should receive deck, right? And return deck. So we haven't actually defined what deck is. I'm going to do deck, FlexMock, deck. Now the string I'm passing here is just kind of a description of what this thing is. It doesn't really matter what the string is.
Right.
So test dealer draws card from deck. I'm going to rename this because our assumptions have changed. Our assumption has now become that the dealer can call draw, but also as a side effect, that removes a card from a deck. Test dealer draws card from deck. I guess that implies that a card's removed, so that's a good enough name.
Yeah. So to explain what these mean, FlexMock dealer, as Marcel says, adds behavior to that dealer object. So it actually modifies this thing in place, wraps it. And we're saying that it should receive a method called deck. And it will return whatever we put here, deck, right? And that deck is just a full FlexMock object that we can put expectations on.
So we want to do deck should receive draw, right? And return card, right?
Yeah.
So as before, since we've already defined our card, and maybe we shouldn't have if we had started really top down, the way that Ian suggested. But at this point, we already have the fact that this is expecting an argument, so I don't think it's a big deal to just do that right for now. Or do you have issues with that?
I don't, but I don't know why you're not using your private method for constructing it.
Thank you. He was saying he doesn't have issues with us making this a king somewhat arbitrarily, but he did have issues with me not using card with face, which I had already defined. Okay, so since the font's so big, it's kind of hard to see this all in one. I don't really need to see my drawer here, so I'm going to...
So what this does is actually sort of add those methods to the objects and have them return a value, right? So we've stubbed at this point.
Okay.
Is that true?
I would defer to Bruce.
No. See, what we're doing here is when we say should receive, that's setting an expectation. This test will fail.
But it won't yet.
No, it won't. I'm about to add that.
Yeah.
Okay. No, yes, that's a step.
Okay.
So this is a stub.
Yeah.
One thing.
So the measurement is so. Remember when we said that the usage model for the stub.
Oh. This one.
That's
The good news is, if there are speakers here, they've seen us go through this enough. Here. Okay. You've seen us go through this enough.
Okay. Okay, so remember that we said the usage model for a stub was we're basically going to record the expectations and play them back. And the usage model for the mock was that we record the expectations and then we play them back, and then we measure the expectations against the result. So, but the FlexMock library is going to do that implicitly. So you don't really see, whether it's a stub or a mock, you really don't see that in comparison test. Does that make sense?
Yeah, so right now...
So here, there's an implicit step. Did all of our expectations get fulfilled if this is a mock? Now, FlexMock's new to me.
We're going to add that in a second.
Okay.
So right now, all that we've done is we've said this dealer or this deck object. So what we've said is this dealer object that exists hasn't had an implementation of deck yet. So we want to pretend as if there's an implementation of deck. And so when we call the deck method on this dealer object, we want you to return this deck object.
So stubbed out deck, basically.
Right, so it's a stubbed out deck. But what we're about to do is we're going to qualify this and say deck should receive draw and return card with face dot once. And by adding the dot once, it means that not only if we invoke this method on the object will it return the card, but if we don't actually invoke it, it's going to fail the test because we're expecting this method to be called once. And if it's called twice, it's going to fail also because even though it's returning what we expect, it's not doing it in the way that we're expecting. It's not doing it the number of times we're expecting. So we're both simulating an interface and also expressing an expectation that that interface is exercised. Right?
And so that adds an implicit step to the end that's going to measure the expectation against the actual use of the API.
Yeah, it's kind of like the last line says, assert that all the expectations were matched, but we don't have to type that line.
And also I'm also assuming that FlexMock is that the dealer is going to call deck once, right?
Yes.
So let's just summarize our expectations. When the dealer draws a card, it's going to have a deck available to it, and once it's fetched that deck is going to have a draw method available to it, and that draw method is going to be called once. So both of these things are going to happen once.
So we truly are testing what the dealer is supposed to do without getting into testing what the deck is supposed to do. Later we can define what deck does via saying when you say draw, then there should be one less card in the deck and that sort of stuff. Is there a question or comment? Yeah, the implicit trigger to enforce these expectations is actually the fact that we put that dot once on the end sets it as an expectation that will be measured.
So how does it actually work? Is your question? Yeah, so his question is we've specified once here, but what code makes that assumption true or false? How does this test pass or fail based on us setting up that expectation of it being called once? And the way that works is it's implemented internally by FlexMock. So when you add FlexMock test unit, it's automatically wrapping setup and teardown so that it can add a teardown that checks what happened. It checks what happened based on your expectations, and FlexMock will make the test fail if you don't meet those expectations. So I think we have everything that we need to run this.
Mm-hmm.
Okay, so if I bump this up, the very question that you had is now being addressed. It says, in mock deck, method draw called incorrect number of times, one expected, but was 0. So
because we haven't implemented the deal or draw method correctly yet.
Right. We haven't implemented. Oh, have we even implemented it?
Yeah.
Yeah.
You just do card button.
Yeah. So this is interesting, and here's where the expectations become valuable because we had implemented. One second.
Sorry, he's going to rap for a little bit. You guys just sit tight.
It's funny you should say that because Patrick is actually an excellent rapper.
For serious.
Yeah. Oh, lame. Okay. Comic relief over.
So this is interesting because if we look back at our test, here we're asserting that dealer.draw returns a card, and that is true technically because here we're just having draw return a card. But our expectation is that the way that it gets that card is by removing it from this deck, and that we've called deck to call draw from deck. And none of that stuff's happened, so our test is failing. But we're also not mucking into too many of the internals because we're thinking abstractly about how the mechanics of this thing actually works at a high level. Meaning, there's a deck and we're drawing from the deck. We're not going, is this instance variable set or something, something like that. So a sort of really naive test without this mocking in place. Here's the thing. We would either have to, without the mocking, write a lot of code just to make this test work, or write a really high-level test that only tests that a card is returned and doesn't actually test the interaction of these other objects. So one of the benefits of using FlexMock here is that we're thinking about this stuff at a high level now in the early design process, and we can come and incorporate stuff like decks and the behavior and interactions they have with dealers without dealing with actually implementing that, right? Dealing overloaded.
There is a little philosophical friction here for me in that are we testing what we're expecting, or are we testing the implementation?
I think so his question is, are we actually testing what we're expecting, or are we testing the implementation? And the answer is we're kind of doing both, but it just so happens that our expectations happen to map to a really expressive our expectations map to an expressive implementation, which seems like implementation details.
It kind of feels like when you tested in design, right?
Yeah.
To kind of design the implementation of what we're going to do.
Well, here's my argument. My position would be that for me, the greater benefit of TDD is the fact that it happens to verify all your code is a nice side effect. To me, it's about the opportunity to think about design and designing your API. So it's a design process first and foremost to me.
And so what's your name? So Rick's point is that we aren't actually testing our code. I mean, I would assert that we are actually testing the dealer and not the deck. So essentially, the stubs and mocks serve to isolate the dealer from the deck for the purposes of this test case. So that getting back to, I'm sorry, I forgot your name.
Sandy?
So getting back to Sandy's point, we make the test a lot less fragile and brittle.
Yeah. If you change deck in some way, it shouldn't necessarily cause your dealer test to fail. Right. Yes, and that's why I said I would leave them as mocks, because I want to test dealer and not deck. Later I'll test deck.
So we noticed that when we ran this, it failed. And it failed because deck was expecting the draw method to be called. Oh, right. Actually, we should have put this expectation first, because this is actually the order in which it should happen. The dealer uses the deck, and the deck gets drawn from. So if we change the order of this, the benefit of doing that is that if we rerun this test, it doesn't. I was expecting FlexMock to actually say dealer expected to call deck, but didn't. So maybe I'll send Jim an email about that.
Yeah.
Not right now, though.
That should receive draw.
Yeah.
You actually write it, that should receive draw once. I think actually.
Yeah. Yeah, the reason why I didn't, so his point is, instead of writing should receive and return dot once, you can say should receive deck once and return. And that is a nicer way of doing it. The reason why I didn't do it is because I wanted to present the concepts in that order. But now that he's mentioned that and we've presented the concepts, I'm going to refactor this.
I mean, the should receive and wants or expectations.
Right.
Right.
Return is really the sub part of the line.
Right.
Right.
Agreed.
So
So the nice thing about this is that we've been thinking about this at a high level, and we have this test set up, and we recognize what's wrong that we need to fix to make it work. But to make it work, all we have to do is deck.draw. And we don't care about the implementation of how that actually works eventually. We just care about figuring out what the API is for all these different objects and what the relationship is. So the implementation of draw right now is just deck.draw. And it's likely that down the road it's going to stay this way, even though we haven't even implemented the deck yet. But when we do, all this stuff is still just going to work. And these relationships are going to hold as they do now. So let me run the tests. Hot diggity.
green.
Verde.
Shoot.
Okay. So deck came into existence here.
Because we say dealer should receive deck once in return, we've actually added this functionality of deck.
So his question is, I don't understand how deck is here.
Yeah, that's the stubbing part. So we're saying the dealer should receive deck in return. That actually creates a stubbed implementation of the deck method on dealer. So we're getting close to the end here, time-wise. We have
Let's, okay, go ahead.
two things that we want to do. One is see how our coverage is, right?
Right.
The other is someone has been following along with R-Spec. Yes, there you are. And I've forgotten your name already. Blake Waters has been following along with R-Spec. Do you have a USB key, or you want to just plug in? Okay. So we're going to look briefly after we do the archive thing. You're making a Rake file.
I'm just going to do this really quickly.
Okay.
I'm creating a Rake file. I assume that a lot of you know what Rake is, but in case you don't, it's basically a Ruby version of Make that allows you to, in pure Ruby, specify all kinds of automation tasks. Test. So I'm creating a namespace, and I'm going to create a task called coverage. And what this task does is it check test coverage. And it's going to do, I'm just going to shell out to do this, archive star test.rb, and then system open doc index, or not doc, coverage.
Open is a Mac thing. It's
It'll
like
open it
Start
up in
in
the browser.
Windows.
So let me see. Sweet. So it just ran coverage, and then it opened it up in the browser, and it turns out that we have 100% coverage right now. Total lines, 31 lines of code, 25. If we actually click on this, it's not that interesting because it's all green. But now we're all set up so that we can sort of integrate this into our testing back and forth. We'll get to points where we'll go, let's just check whether or not we actually have covered everything. And these kinds of things are nice because they can make you not think about the details. Like, you don't have to worry about this. You can forget about it and focus on the design, and then every 20 minutes or whatever, you can go, oh yeah, what's the coverage like? And then refocus what you're working on. But for now, our coverage is fine.
Yeah, I usually check it when I commit my code before I commit.
Sometimes I check it when I'm not sure what I have to do next.
Yeah. If there's anything red, then at least you can do something productive, right?
Yeah.
Yeah.
So his question is, most of his development is in Rails, so does Flex, Mock, and Archive, all that stuff work with Rails, and they all work fine?
Yeah.
Yeah, the archive report that I showed earlier, that's on our Rails project.
So the archive, the stuff that Bruce showed earlier is on his Rails project. Yeah.
With archive, let's say I'm using a ternary operator on the line. Will it pick up both? Will it know coverage-wise if I go down the
If you have tests that happen to invoke both branches, it will. But if you don't, that's the whole point.
Right, but it can't flag me that,
Oh, right, because it's all in the same line, you're saying? That's
Yeah.
true. Send bug reports.
Yeah, when I was joking earlier about my test coverage, like I have this Facebook library I'm doing, it's 99.8% or something. There are 3 lines that aren't covered, end is what's on them.
Which is a bug.
So, yeah. But archive is really good considering the fact that it doesn't actually insert itself into the interpreter, So, we should move along.
To the R-Spec thing?
Yeah. Are you ready with R-Spec?
The Rake file? Oh, and by the way, so he wants to see the Rake file, and if...
Yeah, come on up.
That's the wrong
Blake.
thing. So here I'm doing system archive blah. There's actually like an archive task that comes with archive. So you can just do like archive, I don't know what it's called anymore, but and then you just end up doing like something like that.
Oh, there is an archive task now?
Yeah.
I didn't know that. That's good.
You can do stuff like that, and it'll automatically do that. But the reason why I don't use this is I like to do system open coverage. Like I'll usually do system open coverage if Ruby platform Darwin.
So if you're on Mac OS, then do that.
So,
All right, so Blake is going to show us his version of the same stuff using R-Spec. While you're hooking that up, we sort of talked about R-Spec before, but it confuses a lot of people. So, we have this test unit thing that ships with Ruby, and it has for a long time. Nathaniel wrote it. Actually, the first Ruby conference, Nathaniel did a presentation on precursor to test unit. So old, good software, solid. R-Spec comes along, completely re-implements a testing framework, but in the name of this thing called BDD, which is behavior-driven design or development. Yeah, BDD. So the reason that R-Spec exists is to drive the way you think about testing. We kept, like all 3 of us at one point have said, this is not actually about testing code. This is about driving your design forward, making it more productive. Really, it's about specifying what you're about to do and then doing it, right? So behavior-driven development or design is actually just sort of a movement and a codification of the way good test-driven developers already think. The benefit of using it, I think, is because the framework sort of forces you into that way of thinking. You don't have to explain to people who are sort of new to test-driven development these concepts because the framework pushes you toward kind of the right behavior. So anyway, I'll stop babbling.
Right. So can you guys hear me?
Can you hear? No, not in the back.
All the way up?
So just, raise it up.
How's that? All right. So I followed along from the very beginning, doing this in R-Spec. And like they said before, you can do all of this with test unit. R-Spec just kind of codifies the ideas and lets you write, like, instead of having to write test and then your unit names in a certain format to be more descriptive, you can just kind of write in English, and it has the mocking and specking baked right into the testing framework. So earlier when Marcel, when they were using the ATDR accessor, I said, why not you just make it return king? And you'll notice my implementation still does because I stubbed it, because I used mocking and stubbing to do the implementation in here. So you write your methods in English, so it's like it should do this, and you're specifying behavior and being more declarative. And instead of using assertions, you use should. And so it sort of inverts it. Instead of assert this and then compare it, it's this should be like that or should not do this. So car.new should not raise an error. And of course, you can run this in TextMate the same way. There's a TextMate bundle, and it's just a little bit nicer, I think. Way
Also,
of doing
show
it.
them the specs
The
on
Spec
the
Talk?
yeah.
Yeah, okay. Yeah, the other thing that's nice is that you can, if I can get my terminal back on here, you can generate Spec Talk. I made a Rake file for all of this too.
Bump the font.
Oh,
Bump the font.
sorry.
Just do.
Are we going to be reading it on that screen, or will it be HTML?
It will be, I'll show you the English, and I can generate the HTML if I can remember the syntax.
Okay.
Just do it on the screen.
Yeah, that's fine.
All right. So, well, it puts it into a file, so I'll just jump back
Oh,
to
okay.
TextMate. And let's see. So here's the Spec Talk. And so it generates you an English description of the behaviors of your system, which I think is really nice because when you come into a new code base, the first thing you want to know is how things work. And you can either start reading tests and trying to infer behaviors, and if they were written descriptively and sort of behavior-driven in test unit, then you get some of that. But in R-Spec, it's just the way that things are. So here we have an English description of the entire system, the domain models of it, and how each one behaves. And so you wind up with very short descriptions of each behavior in English.
So Blake, these come from the specify method and then the it method, right? So if you go back over to the
Right. Let me jump to card since that has the most meat. in
the
it.
describe method, sorry.
Right. So it's describe, and these are when you're doing describe, you're specifying context, and so you can actually give a string argument after the describe card to describe different states that your domain model is going to be in when you start describing it. So in a larger system, you'd have a lot more of these. But in here it just makes sense that we were just starting from the very beginning. Go through there. And the other R-Spec also has archive support built right in, so you can do spec archive. And now we can see that I also have 100% coverage as I've been following right along with all of the examples. Is there anything anybody else would like to see or questions? I have not. I've been doing R-Spec for about a month and a half, and I was in the position of starting a new library. So I started from scratch. So I haven't done that, and I have a pretty large Rails application that I've started writing new code in R-Spec, but I haven't tried to convert it because it's just so much code.
Oh, show them this also. The question was, do you
yeah,
use YAML to test? Was the question, which is
YAML to
something
spec.
YAML to spec. Excuse me.
Right. Right.
Right.
Right.
So before you show that,
So you can implement the test actually as a document that then generates the
So
spec.
before, when we were in test unit, let's say Chad and I are having a conversation about something, or like the thing that guy mentioned about down the road, wouldn't this behavior be on this other object or whatever? If I agreed with him and I thought that was true and we wanted to do that, but not right now, I could have written a test some expectation that I have, and then since I don't really know how it's going to be implemented, I could in test unit write flunk and then a string saying this won't be implemented until X, Y, and Z. And then when I run my test, I'll have a failing test, and it'll say this flunked, and it'll give the string saying Y. So I can use that as a reminder. But if you're using stuff like continuous integration, having stuff like that will break your build when it's not really something that should break your build because the test is failing because it hasn't been implemented yet. It's just there as a reminder. It's not a red flag that your stuff is broken. So R-Spec implements a specific mechanism to take that approach, but it takes a different approach where tests don't fail. So this is
Right. So when you do a specification with it and then a string, if you don't pass it a block to define the example, it marks it as being unimplemented. And you notice when we ran, so it says, up here where when the specs were being run, the one with the asterisks is an unimplemented. And if we run the full test suite, you'll see that we have 17 examples with no failures and one not implemented. Which I found when I'm trying to define a model, but I don't really care or know how it's going to work. I put down a lot of unimplemented to try and just kind of get my head around what I'm trying to write before I start putting code down and getting married to it.
As someone who doesn't use R-Spec, it's this kind of stuff that makes me think, yeah, it would be nice. But I just want to add it to test unit. So I think we're out of time. Am I right? So probably, I think we're even out of time for questions. So fortunately, Nathaniel is here and willing to answer any questions you have on testing through tomorrow night. But seriously, after this or whenever you want, we can talk testing. You should all be very proud because you've not only donated to charity, but you spent 2.5 hours talking about testing, which is a really good thing. So thank you very
guys
much.
totally figured out how to improve all the stuff we were doing.
That's
right. Great.
And by we, of course, we mean Marcel.
Right. Improve.
So thank you very much, and we'll see you around the conference.